All right, welcome back, Algebra 1. On your 1-4J notes for today, we are finishing up our exponent rules with our raising a quotient or a division, like a fraction, to a power. So let's just finish up or review what we had talked about yesterday with this bell ringer. So again, first thing that we always want to do is if we see something that does not have a visible power, we want to make sure that we fill that in with a 1. And then go through and do your exponent rules. So here we go. First thing that we do is we see these numbers out front here, and if we can divide them, we want to do that. Now, let's say, for example, if this was like a 12 divided by 7, they don't divide evenly, so we would just leave them alone. But these divide nicely, so we're going to do that. 12 divided by 3 would be 4. And then what we do is we take our variables, since they are being divided, we would go ahead and subtract the exponent. So a to the third divided by a to the second, we would subtract 3 minus 2. And then for b to the first divided by b to the fifth, we would subtract 1 minus 5. Next step, just go ahead and subtract those numbers. 3 minus 2 is 1, and 1 minus 5 is negative 4. So since I don't have a fraction, I'm going to make it a fraction because I recognize that I have a negative exponent, and that's not okay, so I make it a fraction over 1. I identify the problem, and I move the problem. So move the b to the negative fourth down to make that a positive fourth, and there is your final answer, and we are finished with that problem. All right, so what we are doing here for this the notes for this one, basically if we have something dividing here and we have a power on the outside, just like when we had something before, we had something like let me get a pen up here. So if we had something like x to the a, oops, let me back up there, x to the a, and then y to the b, and that was all raised to the c. We would basically just take this and kind of like multiply every exponent on the inside here by that exponent, and we would have x to the a times c, and then y to the b times c, and then we would just multiply that through here. Same thing, we're going to take this and multiply it by all of the exponents on the inside, and then just kind of like distributing that through there. So same thing here. So, but just like before, we're going to start it off by anytime we don't see a visible exponent, we want to make sure we fill that in. And then we're going to take this number on the outside and we're going to multiply that by every number on the inside. So x multiply 1 times 4 is 4 over, and then take this 4 and multiply it by the 3. So it'll be y, and then 3 times 4. So the final answer here would be x to the fourth, and then 3 times 4 would be 12. Okay, so that is your final answer for that one. Now, you don't have to show this 3 times 4. You could just do that and get 12 for your answer. All right, so let's follow along with me here on this one. And you can see here I did fill in this, all the ones there. I just put anything that didn't have a visible exponent, I just put a 1 in there. So you can see that I have that there. So now I'm going to take this 3 and just multiply that through. So 3 times 1 will be 3, so I have 4 to the third. Oops. N had a 1, so 3 times 1 again is 3. 2 had a 1, 3 times 1 is 3, and n had a 2, so 3 times 2 is 6. So let me scroll down here. There's a big gap in those. So that's what you get when you multiply that exponent through. So the next thing I did was I actually went through and did my exponents. So 4 to the third power is 64. 2 to the third power is 8. And then just like in the bell ringer, since this is a nice division problem, I'm going to do that. 64 divided by 8 gives me 8. And then we subtract the powers. So 3 minus 6. Okay, and then 3 minus 6 gives me a negative 3. Let's get rid of this here. 3 minus 6 is a negative 3, which again, and that's a problem. We can't have negative exponents, so make it a fraction over 1. Identify the problem and move it. So here's your final answer. Once we move that down, 8 is left on the numerator, and then n to the third power is on the denominator. Next. Again, 3 over 5, what we want to do is we want to put a power of 1 with both of them. Negative 2 times 1 is negative 2. Let's just get rid of this whole thing here. So we have 3 to the negative 2, 5 to the negative 2. They're both negative, so we're going to switch them. 5 squared over 3 squared. And then just go ahead and do that. 5 squared is 25. 3 squared is 9. Since this does not simplify, it doesn't divide evenly, we're just going to leave it like that. We don't want to change things to mixed numbers. I know some people are saying, well, 25 divided by 9, if I put that in my calculator, it does give you a decimal of like 2.7 repeating, or if you change it to a fraction, it might give you like 2 7/9 or something. We want to kind of get away from mixed numbers and stuff like that. So 25 over 9 is how we want to leave this, okay? All right, next, let's do this one together. So first of all, I recognize 7 does not have a visible exponent, so we're going to put a 1 there. Now we're going to multiply this negative 3 through. So negative 3 times 1. We're multiplying this by the exponent, not by the number. So we don't want to multiply it by 7. We want to multiply it by the exponent. So 7 to the negative third. And then a, we're going to multiply the negative 3 times the 2. So that's a negative 6 over, and then we have negative 3, we're going to multiply by the exponent. Negative 3 times negative 3 will be a positive 9. Okay, so now what you should recognize here, and this is why I wanted to do this one, is that this is a negative exponent. That needs to be moved down. But then also this is a negative exponent, and this needs to be moved down. So what we should realize is that nothing is left in the nothing is left in the numerator, and what that means is that we're left with a 1. Okay, so the 7 to the third got moved down, that's a positive 3. A to the sixth got moved down, that's a positive 6. And m to the ninth was already there, so that's just going to stay there. And then in our calculator, we do 7 to the third power. Oops, I didn't want to write that. 7 to the third power gives you 343. So we have 1 over 343. And then we're just going to rewrite the rest of this. A to the sixth and m to the ninth. And now we are finished. Make that a look a little more like an a and a little less like a 9. There we go. So here's your final answer for this one. Okay, so I wanted to walk you through that one there. All right, next one. I have this one done for you. So again, go through this one with me here. And I know we have two m's here. You could do that exponent rule first of the dividing and subtract them. So you could start off with having 2 and then subtract them, m to the third, just by doing 5 minus 2 and 2m to the third, and then raise that to the negative fourth. Like you could start off with that exponent rule. But I started off using the exponent rule that we were learning today, and I multiplied this through here. And then I went through that exponent rule first, but it doesn't really matter. You could do it either way. All right, so let's go through this here. Multiplying that 4 through. Here we go. Negative 4 times 1 gives you 2 to the negative fourth. Negative 4 times 5 gives you m to the negative 20th. And negative 4 times 2 gives you m to the negative 8th. So then what I did was I brought my 2 to the negative fourth over, and then I subtracted these. So I had negative 20, the top exponent, minus the bottom one. So don't forget, this is a double negative right here. This is a double negative, which will be a positive. So if you had a negative 28 here, that's an error there. So you should end up with a negative 16, because that's a negative 20 plus 8 after you do that negative double negative becoming a positive. But either way, now I have a negative 4 in my exponent. That needs to be moved. I have a negative 16 in my exponent. That needs to be moved. So I can see here I have 1 over 2 to the 4th times m to the 16th. 2 to the 4th is 16, m to the 16th. So here's your final answer for this one. And the last one, to simplify this, we want to know which of these options, A, B, C, or D, is equal to this. Now remember, none of your exponent rules as far as subtracting these exponents apply here because the bases are not the same. So we want to see which of these will apply, kind of working backwards. So what do you think? Well, the only thing that works here is A, because this exponent of 3 getting multiplied by the exponent of 1 for the 6 and the exponent of 1 for the 7, that's what's happening there to end up with this to give you, 6 to the 3rd over 7 to the 3rd. Okay, so that's the only thing that we can do there. These ones down here are kind of looking at like, well, if we subtract the exponents or something like that, but those do not work. The only thing that works is A. So let me erase all that other stuff there so you can see what's happening. So if we have this 6 over 7 to the 3rd, if we take that 3 and multiply this power of 1 and this power of 1, we end up with what we have here. All right, so again, if you have any questions, let me know or rewind the video and see if you can figure out what the problem is just by watching the example over again. But if you're still not sure, just let me know and send me an email or a private comment or ask me in class, and we'll see if we can get the problem figured out.